Can you run local LLMs at full performance on an external GPU? I connected my budget Intel Arc A770, 16GB of VRAM, to a mini PC via OCuLink. No tower, just a cable and a dock. We are testing Qwen and Gemma models on the setup, dance and MOE, and finding out whether OCuLink actually costs you performance compared to a full tower setup. Let's start with the hardware. The Arc A770 16GB of VRAM picked up secondhand for around $200. You've seen this card in the previous two videos. We'll connect it to the mini PC using this OCuLink cable. For a stable connection, keep the cable length at 0.5 meters or below. The mini PC runs an AMD Ryzen H255 CPU, 32GB of DDR5 5600, Windows 11. And this is the OCuLink port, PCIe 4.0 at X4, that's 8GB per second, direct, no protocol translation. This is the OCuLink dock, the OCu-P4 V2. I bought everything myself, this video is not sponsored. The PCIe X4 slot for the GPU is here. GPU and PSU can both be fixed with screws. The OCuLink connector is here. Don't be confused by the USB label. The manufacturer uses the same housing for their USB 4 dock as well. The status LED is quite bright, so I've covered it with tape. The PSU motherboard connector goes here. The PSU is external, a Corsair unit. The fan doesn't spin at all below around 30 to 40% load. I also tested the dock with the built-in PSU, but the small fan runs constantly and is genuinely loud. Went back to the external PSU immediately. The modular design lets you omit the cables you don't need. Make sure to mount the PSU so the internal fan doesn't blow directly into the GPU. The A770 limited edition has a bright LED light show. To switch it off, you need a special RGB cable connected to the A770's USB port. Normally, that goes to a motherboard USB header. In a mini PC setup, a short USB-A adapter cable does the same job. I have the LEDs turned off on my desk, less distraction while working. And this is the whole connection, one OCuLink cable. But Patrick, only one GPU, you might ask? Someone in the comments on the dual GPU video actually connected two RTX 5060 Ti cards to a mini PC. One via OCuLink, one via USB 4. I'm thinking about trying something similar. Drop a comment if that sounds interesting. One quick note why OCuLink and not Thunderbolt 4. OCuLink is a direct PCIe connection, no protocol overhead and no Thunderbolt licensing fees, which is why the docks are significantly cheaper. The downside? No hot plug, you connect before you boot. One practical tip for this setup. Sleep mode leaves the PSU drawing power even when the GPU fan stopped. Use Hibernate instead for longer breaks. It writes RAM to disk, shuts everything down cleanly including the dock, and on wake up the whole setup comes back automatically. When I choose this dock, one thing mattered. The PTN3222 redriver chip. That's a signal amplifier built into the dock. It keeps the PCIe signal clean over the cable. Cheaper docks without it can have stability issues, worth checking before you buy. On the left LM Studio, on the right the Windows Task Manager. The Arc A770 currently shows a base load of 1.4 GB, two monitors connected. The mini PC also has an integrated GPU, the Radeon 780M. Windows has allocated 8 GB to it. I'd set 2 GB in the BIOS, but Windows adjusted that on its own. Now, even though the 780M is clearly visible in the Task Manager, when we look at LM Studio's Hardware tab, only the A770 appears as a selectable GPU. The integrated graphics show up combined with the CPU in one line, not as a separate compute device. LM Studio uses Vulkan for GPU inference, and on Windows the 780M doesn't expose a dedicated pool that Vulkan can address independently. ROCm on Windows is technically possible, but requires significant manual setup. And even if it worked, the 780M shares the same DDR5 5600 memory bus as the CPU, the same bandwidth pool, the same ceiling. It would not meaningfully outperform CPU-only inference on the system. So, no iGPU path here. CPU solo or A770 via OCuLink, that's what we're testing. Let's quickly look at how the CPU handles inference, just long enough to make the GPU numbers hit properly when we get there. Runtime CPU only, KV cache offload of pure CPU, no VRAM. Qwen 3 14B Q4KM around 8 GB. CPU utilization lands between 50 and 60%. The memory bus is the bottleneck, not the processor. Nothing loaded into the 780M. 4 tokens per second. Usable in a pinch, not something you'd want to work with daily. Qwen 3.5 35B MOE at IQ2M around 12 GB. IQ2M is chosen for size, not for quality. It fits cleanly into the A770's VRAM later. In real use, Q4 or better. 10.4 tokens per second. MOE helps significantly even on CPU, but these numbers are just the baseline. Let's see what the GPU does. One thing worth mentioning. I had to move both monitors from the A770 to the integrated 780M. Display output on the A770 was measurably affecting inference performance. So from here on, the A770 is running as a pure compute device, exactly as it was in the tower setup in the previous 2 videos. Also for Arc GPU users, make sure resizable bar is enabled in your BIOS. I covered the BIOS settings in the dual GPU video, link in the description. Before the model benchmarks, one quick measurement. This is clpeak, a bandwidth test run on the A770 via the Vulkan backend. Host to device 5.68 GB per second, device to host 5.75 GB per second. For context, PCIe 4.0 X4 has a theoretical ceiling of around 8 GB per second in one direction. But after protocol overhead, real-world measurements on desktop systems typically land between 5.5 and 6.5 GB per second. PCIe 3.0 X4, the second slot on many consumer mainboards, runs at roughly half that. Our OCuLink connection is right at the top of what PCIe 4.0 X4 realistically delivers. That's a strong result for a cable-based external connection. And remember, once a model is loaded into VRAM, the PCIe link becomes irrelevant for inference. It's the VRAM bandwidth that drives tokens per second. 512 GB per second on the A770 versus 89 on the DDR5 system RAM. Runtime Vulkan. Hardware A770 enabled, KV cache offload on, Qwen 3 14B Q4KM. GPU offload maximum. Flash attention is on, and in this setup, unlike my tower, this doesn't cause any issues. No garbled output, I'm leaving it enabled. The A770 is running at 97% utilization, and the limited edition with its 2 fans stays remarkably quiet at this load. 25 tokens per second, from 4 to 25, and identical to the tower. OCuLink X4 versus a PCIe X4 slot, no difference on inference once the model is in VRAM. Now the MOE model. Qwen 3.5 35B at IQ2M, in real use take Q4 or better, but for this performance test the file size fits cleanly into VRAM. GPU offload check, Only 36 of 40 layers loaded, slider to maximum, reload. A770 utilization again over 90%. 52 tokens per second. As long as a model fits completely in VRAM, OCuLink makes no difference on inference. Model loading may take slightly longer compared to a PCIe X16 slot in a tower, but compared to any X4 slot, the difference is minimal. For completeness, Gemma 4 26B at IQ3S around 12.5 GB. Normally you take Q4, but this size pushes the VRAM nicely. Another MOE model, speed should be in the same range. GPU offload check, only 26 layers loaded, slider to maximum, reload. A770 utilization again over 90%, slightly higher than with the Qwen model. 35 tokens per second, identical to the tower. Consistent result across all three models. OCuLink delivers full inference performance. The connection is not the weak point. So what does a mini PC with an external GPU via OCuLink actually deliver for local AI? The OCuLink connection costs you nothing on inference performance. The numbers match the tower across the board. Model loading takes a bit longer over X4, that's the only real trade-off against the tower slot. Against the Thunderbolt eGPU setup you're also giving up hot plug. What you get in return is a setup that runs the same models at the same speed. Now it's up to you. The USB4 eGPU dock just arrived. Do you want to see the mixed dual eGPU setup, OCuLink and USB4 together? Or would you rather see the A770 on Linux to check whether latest drivers perform significantly faster than on Windows? Write it in the comments and subscribe so you don't miss it. If this was useful, a like helps the channel to reach more people. The dual GPU video and the Gemma 4 video are linked below. Thanks for watching.